The climate crisis is the biggest challenge of this generation. We absolutely need to avoid that the temperature is further rising. So we need to come to a much more integrated concept using energies which create less or no CO2. One key sector where we need to focus on avoiding CO2 is the process industries. And we have to do everything to come to a climate neutral and to a more decarbonized way of feeding energy into all these industries. Siemens, as a key provider of digitalization, automation and electrification, can support changing over these industries to a CO2 neutral future and come up with a much more integrated energy solution across all different sectors and across the globe. What we are going to address in the arena of decarbonization to become a CO2 neutral or to become more CO2 neutral is especially applications in hydrogen.
Siemens Smart Infrastructure built and operated a plant in hydrogen, a green hydrogen plant in Wunsiedel. That's located in Bavaria in the Fichtelgebirge, which is a nice area. I will show you where Siemens products and systems help to get this operation safe and profitably. So look behind me, there you see all the package units that surround the electrolyzer, the shining star that you see here in green color. You see there's a lot more to it to make a plant run smoothly. You guys seeing the electrification here starting from the transformers, low voltage switch gears, medium voltage switch gears, the water pathway for the process water, the purification, because what you need, the electrolyzer needs the ultra clean water, which has kind of pharmaceutical quality. I will guide you through two of those places where Siemens products help to make that operation smooth, safely and profitably. So here you see the electrolyzer in a way we scanned it. We did a 3D scan that allows you to basically run through the plant. We give you a small introduction here. See, I can move that around. We can go to different places and walk around. And yeah, so you see a electrolyzer. The make and model is Siemens Energy. It's a Silyzer 300. It's a half of stack. And let's take a look. Let's take a look at the top view here. So here you see nicely how the Siemens instruments line up. You set the temperature transmitters in green color. You get pressure transmitters here all over to the right, and you'll see flow transmitters. So this is the basis that give us signals in the control system that ultimately controls the entire plant. And so there is hydrogen is a gas that is explosive. So we have a lot of safety equipment installed in this place. That starts with the HVAC system for the entire building. We measure there are gas detectors under the roof. Hydrogen, in case there is a leakage, moves up to the roof. If hydrogen is detected there, it will trigger an emergency shutdown system. Flaps on the roof will open automatically so that the gas can go out into the atmosphere. However, if there's something wrong with the electrolyzers, that is hard to detect, and there is a gas analytical cabinet that I'm going to walk to in a minute. So I'm talking about in a minute, it's located here, but I first want to discuss a little bit the water purification. This is where fresh water is coming in from the community, and it works in a way, we call it reverse osmosis. It's a concept you may know from your dishwashers at home. You eventually have to replenish the salt every once in a while, and that's exactly what you see here. So these bags are full of water, full of salt that have to be put into that white box here once a day. Next to it is the gas analyzer cabinet. We are taking gas samples from the gas separators that are on top of the electrolyzer, and it's pumped constantly to that place here where we analyze the amount of oxygen that comes in on the hydrogen side. There's always a little bit of oxygen on the hydrogen side, up to 0.5% is totally normal. However, if we get close to like 2%, then there is potentially something wrong with the membrane or with the stack. So if there's an unusual amount of oxygen, also here we need to trigger a safety system, an emergency shutdown system, to make sure that we are not reaching explosive levels of hydrogen-oxygen mixture. So this is the reason also why this is a safety integrated instrument here, and it's fully redundant. You see SIL2, which stands for Safety Integrity Level 2, which is gets a TÜV approval. The safety instruments, that's a topic of itself. Basically, they monitor themselves. In case they self-detect an error, then they shut themselves down. This is also the reason why there is redundancy built in here. We also have the same concept on the other side. So the next cabinet over here does the other thing, where we look at the hydrogen level on the oxygen side. The instrument we use is a Calomat, safety again. I forgot to mention the name of the oxygen analyzer. That would be the Oxymat Series 6 in this case. Yes, so I think this is quite a nice overview about the electrolyzer and its safety relevant components. I would like to close with the control room, where you see where all the signals nicely line up, and we have the balance of plant, and this is basically where the whole system is being operated. It's an unmanned operation most of the time. We have also remote access possibilities, but let me first walk to the place. So here's the entrance of the control room. I walk right in. Oh, magically opens the door. Yeah. And this is the operator place. Let me first start with the engineering and operator station cabinet. You will see a couple of industrial IPCs here with a lot of switches where all the signals come in, and we supply basically all the data that you will see on the screen. All the graphics come from here. And this communicates with the control station, the AS, and that's in a different cabinet. So this is it. You see the S7410 controller up here, where all the logics are being executed. The I/O modules down here. The yellow color indicates also safety, functional safety. So this is where the magic happens, and ultimately I would like to finish with the picture that an operator looks at. So that's the one. Here we go. This is exactly what you see when the plant is in operation. You might have noticed in the previous picture there was not such a nice picture. Yes, I did that scan when the plant was down, of course, then otherwise I wouldn't have been able to go everywhere, and I wouldn't have been able to open the cabinets. So this is a screenshot that we took at the time when the plant is up and running. And yeah, you can see a lot of details. The electrolyzer is right here. It goes into a buffer that separates the electrolyzer from what we call the low pressure or medium pressure compressor. So that's this area here where you build up that pressure of 30 bar, stored in a medium pressure storage after it has been cleaned in a way so that the remaining oxygen is removed. So that's the deoxo unit right here. From the medium pressure storage, we go to a high pressure compressor that fills into a high pressure storage, and from there the delivery is done on a tube trailer filling station. This is the way how this hydrogen is delivered, and I think with that we end that short tour. Thanks for watching. Have a nice day.